All right, your Happy Bio teacher here with another video for you. This one is on standard normal distribution and how standard deviation relates to that. So normal distribution is simply where we have a bell curve. Now my bell curve is not perfect, but it should be symmetrical, so this one should actually probably come out a little further. But it is basically where we say if something is normally distributed, you tend to see more around the mean and fewer at the extremes. An example, let's say the height of women. Let's say average height for a woman is 5'6". I have no idea what it is. Then what we would expect to see is we expect to see lots of women up around 5'6". And then as you look towards the shorter heights, you see fewer. And as you look towards the higher or the taller heights, you see fewer. So maybe down here is like 4'10", 4'11", 5 feet, 5'1", 5'2", 5'3", 5'4", 5'5", 5'6", 5'7", 5'8", 5'9", 5'10", 5'11", 6 feet, 6'1", 6'2". We don't see a lot of women that are 6'2". We don't see a lot of women that are 4'11", 4'10". So that's why these numbers are almost to zero. But we see lots of women in that 5'2" to 5'8" range, and so that's going to be the higher part of your graph. So that's what it means to be normally distributed. Lots of values around the mean, not a lot at the extremes. All right, when we apply standard deviation to this, now standard deviation, if you'll remember, only refers to your sample size. So let's talk about 100 students taking Biology 1, and they took the EOC, and let's say that the mean score for that 100 students was an 80 on the Biology EOC, okay? We calculated standard deviation. That standard deviation was 6 points. So the average amount that a student deviated from that mean was about 6 points. When we're talking about this, though, we can only talk about this 100 students. If I want to talk about another student in California that took the Biology EOC, then I would have to use standard error because that's going outside of my sample size. So standard deviation is only within the sample size that I have. So what we talk about with that is if we're looking at our sample, our 100 students, plus or minus one standard deviation is going to be plus or minus 6. So let's say this is our mean of 80. Let me highlight that a little bit better. Okay, so there's our mean of 80. And if I were to go up 6 and down 6, and if I was doing this like for real, I would actually be counting boxes and such, but I'm not. I'm just kind of playing around with it for your sakes. What we would expect to see is between that range, 67% of our values, so out of 100 students, about 67 of them, about 2/3, are going to fall between a 74 and an 86. Okay, so within plus 6 of that 80 and minus 6 of that 80. So 67%. If we added another 6, if we went 2 standard deviations, so now we're looking up 12 points to a 92 and down 12 points to a 68. What we would then expect to see now is that 95% of our students, I'm going to run out of space here in a minute, 95% of our students would fall in that range. So if you look at your bell curve, this area kind of under the curve and between these lines is about 95%. I didn't do it perfectly, so in reality, this should probably be smaller like this. So this would be this area and this area together would be that other 5%. Okay, so 95% at plus or minus 2 standard deviations. And then if we really wanted to look even further, we could look at plus or minus 3 standard deviations. So now we're looking at 3 6s or 18. So that's going to take us up to 98 on the test, or down to a 62. So the number of students that we would expect to have fallen between 62 points on the EOC and 98 points on the EOC would be another 6. And so that's going to take us to, I'm going to have to probably do this one on top up here, 99%. So plus or minus 3 standard deviations, is 99%. I didn't need the plus or minus again. Okay, and so that is going to be almost all of our data. We have a few down here and a few down here that didn't fall. That 1% is going to be outside of those. They would either be 99 or 100 or below a 62. But that is what normal distribution is, and that is how standard deviation applies to that. I hope that helps, and if you have more questions, let me know.